Hello everyone, welcome to vidura.embedded YouTube channel. In this video, we will see how easily we can implement condition-based monitoring and motor control on a single microcontroller using a machine learning models. In these days, condition-based monitoring and predictive maintenance are one of the major investment domains for the applications in manufacturing. So depending on the reduction of the downtime and the improvement of the maintenance of the cost. Observations from a skilled person can help us to identify when a certain part is going to fail. But some cases, these parts are inaccessible, and even in some cases, it is impossible to access these parts. So this is where the artificial intelligence-based conditional monitoring can help us to solve the problem. Next, I will walk you through the hardware and the mechanical systems that we are using it for this demo. So on the front side, you will see that we have a 1.8-inch TFT display, which will actually displays the classification demonstration that we are using. So which means basically like what is the class and what is the motor speed, whether it is running in a low speed, high speed, or medium speed, or very high speed, and also it will display the score, or basically called as a inference percentage. Okay, so 1.0 is basically 100%. On the top side, we have a timing pulley setup for the simulation, and also we have a load demonstration using a SG90 servo motor. We have a 3-axis accelerometer and gyroscope to detect the vibrations of the motor with various speeds. Okay, and here we have IR sensor through which we are actually controlling the motor speeds using a PWM with different duty cycles, and we are using this remote. This remote basically works with NEC protocol. So on the hardware side, we are actually using the STM32F441CE black pill module, and through which we are actually controlling this entire setup. So USB, we are using it for the data logging purpose to retrieve the data from the accelerometer. We have also quickly developed the PCB to work with this setup. Okay, and we also designed this PCB and ordered with the JLC PCB. Here we have a 12 volts power adapter. Okay, so the entire setup is running with the 12 volts DC power supply. We have implemented this entire mechanical setup, including hardware, in a small form factor with a size of 100 mm by 80 mm. Coming to software part, we are using a Nano Edge AI Studio version 5.0.2 for data logging as well as for creating the tiny ML model creation. So what we have done is we have created a project based on an accelerometer, okay, and also collected the different samples from the USB for various motor speeds. Okay, so if you look at here, we have created an unclassification project, and the data collected for different classifications like motor with no speed, motor with low speed, motor with medium speed, and motor with high speed, and motor with very high speed. So basically it contains 1, 2, 3, 4, and 5 classifications. For motor no speed, here you can see the x-axis, y-axis, and z-axis data, as well as the corresponding effective values for the 3 axis. Similarly, for motor low speed, motor medium speed, motor high speed, and motor very high speed. So basically, what we are doing here is varying the different motor speeds and actually gathering the different vibrations of the motor using the accelerometer. So then we have done the benchmarking for the data that is collected using an NHA Studio, and then we see the best performance, and it reaches the best quality index of 100 points as well as the balanced accuracy of 100%. NanoJ Studio, it will actually do the analysis with different ML libraries, and it will give you the best library out of all the libraries that are available based on the data that we provided during the data logging phase. Then in the deployment phase, we have a provision to download the library. So by default, these options are clicked, and you can click on the deploy library and get the library. So once the library was successfully compiled, we can save this library. Now we can bring that library here into the STM32 IDE. So here also we have created a project, and here I have put the libnea.a file as well as the files that are generated in the library from the NanoEdge Studio, which contains the NanoEdge a.header file as well as the knowledge.header file. Here actually we are collecting the data from the accelerometer, and we are comparing with the classification and printing onto the LCD. Now I will walk you through the demo. So basically, as I explained, so we have implemented 5 classes: motor with no speed, motor with low speed, motor with medium speed, motor with high speed, and motor with very high speed. For each classification, we are going to collect the data from the accelerometer. The data that we are collecting from the accelerometer is the vibrations of the setup. Okay, so let's get started with the demo. So currently the motor is stopped. Okay, and we can see that class detected is motor no speed, and the score is 100%. So that means which is successfully detected. So now if I change to the 30% duty cycle, here you can see low speed. Now we have given a PWM of 50%. So then you can see that for class detected is motor medium speed, and the score is 1.0. Then I will switch to the 70% duty cycle, and here you can see that class detected is motor high speed, and the score is 100%, that is 1.0. Now I will go to the next class, that is motor with a very high speed. Now here you can see that the class detected is motor very high speed, and the score is 100%. Now I have stopped the motor, and then you can see that class detected is motor no speed. If you like this video, please subscribe to my channel. Thanks for watching it.